Okay, after you have understanding the design requirement, so you have to design it. For this design, I think using finite state machine is a good way to implement it. So you have to think about how to design the states. How many states are you needed for this design, and the state transition between them. That is, what's the condition for state A to transmit to state B, and for state B, what's the condition it will transmit from state B to state C. So you have to define the states and the state transmission conditions. If you have synced this clearly, then you can code it smoothly. Okay, this is a reference finite state machine designed by me. Okay, I use these states, and this is the state transition condition. Okay, just take a look at. Okay, this is just a reference. Okay, not the only one design method. You can design your own state and transition conditions. Typically, there are two counters. That is one T count to count for the wait cycles, and there is a C count. That is to count for the consecutive 10 times of D in equal to high and check time. Two counters work with this state, then we can implement this function. Okay, this is something you can do after you have designed it, or you have read and understand the reference design. Okay, I will show you my reference design. This is the directories I used: pattern, RTL, and simulation directory Verilog. And maybe you have the document directory. So in the RTL, I put the design file, and pattern we put the simulation environment, and for Verilog, we put the file list and make file. So let me show you the makefile first. Okay, it's something the same as we used in this guy. Okay, usually we just change the top name and editor the file list file. Okay. Then let's say the design files. We'll first look at the design. So input output defining, and define for states of the finite state machine. So this is usually the same as we have written in the document. Yeah, you can compare. Then we have two counters. Yeah, one counter to count for the cycles, such as the 115 cycles, and one counter to count for the consecutive 10 times of D in equal to high. Then we use the one segment style to coding the finite state machine. So I will not explain the code. Please understand by yourself. Any question? Please send me a message. The design is usually the same as we have written in the document. Yeah. The article code just express the idea in this diagram. So from the idle state to the delay 15 and check state, they are the initial step. Yeah, they are the initial step. That is the step 1. So the 2 state will be step 2. And this is the final state, that is check status will keep at high until the next reset. Okay, that's all for the design. And let's see the pattern. The pattern. Okay, this is the test pattern. First, we give this time scale, and module M define some internal variables or internal signals. This is the generate clock. Okay, this is the technology. You can say this is the coding trick we have explained. Don't align the signals at the boundary of test bench and DUT. Don't align the signals. Don't align the signal transition edge with clocking edge. So we add actual 0.1 nanosecond delay. So when we use this signal D in, we usually use the D in gun buff. Yes, D in underline buff when we use it. So when we use the check status, yeah, that is from the DUT, the output of DUT, we use the check status underline buff. Yeah. Okay. And we define 2 tasks, that is will drive the D in and the reference state. So I define an initial block. In this block, I will give the stimulus using the give 1 and give 0, give 1 task, and I will give some fixed patterns at this point. Yeah, this pattern may be the initial sequence. Okay, the initial sequence. So you can say the idea for this pattern is we give the waveform of D in and we give the reference status. Yes. So there is no reference design. We just give the reference. We just give the reference output along with the input. Then after the initial sequence, we give some waveforms. So there is something to test whether there is 10 consecutive times of D in equal to 1. Okay. That's all for the pattern. This is the checkpoint. The checker, it will check the output of DUT and the reference status. So you may think that this tumulus we generate is not enough. Okay, so you can give more stimulus. Yeah, and generate new test case. And even you can modify the DIN waveform, that is give more 1-0 toggle in these times. Yeah, in these times you can give more 1-0 toggle for DIN. Okay, that's all for the reference design. Thanks.